Okay. All I was about to ask y'all is what the answer is. I heard a 4. And now I'm gonna have to fix it. So this is strictly a notation thing. If I think about PEMDAS in order from left to right, I've got to deal with the exponent piece first. So this says I'm going to square 2, and then I'm going to deal with the fact that we had a negative sign here. If I wanted it to be positive 4, I would be looking at saying -2 in parentheses squared. This guy is equal to positive 4. I would say by far, this is like the number one thing that is just that small mistake that then kind of compounds on itself in the middle of a problem. So I just wanted to address that early on. Now, where the order of operations really comes into play is with my least favorite set of instructions. My least favorite set of instructions is the word simplify. Now, unfortunately, this shows up all over the place. This shows up in lots of different math questions. This shows up in textbooks. Simplify means a whole lot of different things, and we don't usually spell out which of those things we're looking for in a given problem. But let me just give one example here. So if I'm looking at something like if the only instruction is simplify, what do you think you're actually supposed to do? So I like the word solve also, and typically if we're going to solve something, there ought to be an equal sign somewhere in the problem, but I think I know what we mean. And I would say we are looking to get that to a single number, right? So we're going to do whatever we need to do so that that is a single number. I'm going to use this as an example to like walk through our PEMDAS stuff. So if I'm thinking about PEMDAS specifically, parentheses, that P comes first, which means typically I'm going to try to simplify anything that's in parentheses. See, I used that word again. Anything that's in parentheses, I'm going to try to get that down to a single number first. So I'm looking at 3, 4 minus 2 is going to be a 2. 7 times 3, that's 21, minus 10. So now I'm at 11. I've gotten all of the pieces in parentheses as simplified as I possibly can. Now I'm going to go down to my next piece, that E for exponents. I've got an exponent in here, so we're going to simplify that out too. So 2 squared is 4. I'm going to have 3 times 4. And then 5 times 11. Next up, we've got multiplication and addition in terms of following those PEMDAS rules. 3 times 4, I'm looking at 12. 5 times 11, I'm looking at 55. I've dealt with our parentheses, our exponents, any multiplication or division in the problem. Now I'm moving on to addition, subtraction. If I add these two together, I am looking at 67. Good times. It's not going to be super exciting this morning, but I'm going to give you all one to try on your own. I just made it up. I have no idea what the answer is, but if you think you got this down to a single number, check in with the people around you, see if they got the same number that you got. It's kind of like hard to walk around. Seeing a couple of negative 37s, I don't know if that's right, but more than one person got there, so maybe. Just kind of a reminder in terms of goals for this class. One of the big objectives of this class is that you are going to get more accurate and faster with algebraic simplification stuff. So if it has been a minute since you were having to do this kind of arithmetic stuff, either in your head or writing stuff out slowly, give yourself some grace on that. We're going to take this quarter to make some of those things faster. And I'm going to share things that I do along the way. If there's ever a problem where I'm like, oh yeah, I kind of do this little mental trick to do it. The other thing that I haven't shared in terms of homework and quizzes and you submitting work, if you are someone that can look at this and do all of that in your head, I'm totally fine with that. You don't need to write out extra steps for me. If you needed the step to do the problem, I want to see it. And that gives me an opportunity to give you partial credit. And more importantly, to give you feedback if there's something that didn't go wrong in your thought process. But if you're like, nah, I can just do this, don't write out extra steps for my sake. And that's going to be true throughout the quarter, even when we're doing more complicated stuff. Okay, so let's roll. Did anyone get something other than negative 37? Cool. We got a few hands up. So I don't know the answer. Let's figure out what the answer is. Good deal. I'm going to start with thinking about order of operations. I'm going to deal with those parentheses first. So that first set of parentheses, I've got 8 minus 5, which sounds like a 3 to me. And when I'm looking at the second set of parentheses, it's like I get to start over. This is a problem within a problem. So if I look at this problem within a problem, I'm still going to go through that order of operations. So within those parentheses, I'm going to deal with my exponent first. There won't be any multiplication, but then I'll deal with my subtraction. So within there, 5 squared, that's 25. And then minus 30. I've still got parentheses to clean up. Again, I know I'm writing out more steps than most of you would need to, and that's okay. 25 minus 30, I'm looking at negative 5. Next up, I've simplified my parentheses as much as I can. Time to tackle exponents. 3 squared, I'm looking at 9, so I've got negative 3 times 9. Again, I know I'm writing out more steps than y'all need to. It's okay. Next up, I'm looking for multiplication or division. I didn't put any division in here. Fractions are scary. So I'm just going to do the multiplication piece here. Negative 3 times 9. I could come off to the side for a second to deal with it. Let's see how we feel about it. If I multiply negative 3 times 9, is my answer going to be a positive number or a negative number? Okay, people said that with such confidence, I'm going straight into negative 27. If I have 2 times negative 5, positive or negative result? So I am looking at a negative 10 over there. All kinds of different ways we can rate this, but can I get a brave volunteer? How did you know the answer was going to be negative? And I'll focus on the negative 3 times 9 for a second. Any brave volunteers to explain how you knew this? More opportunities to learn names. Hi, I'm Sarah, and you are?
I'm
Tiffany?
Yeah.
Sweet.
So they always tell us that like a negative times a positive is always an equal and a negative, and the negative times a negative is a positive. They even like if you forgot you're like a visual person, they made us do like a chart as well to make sure to remember.
Cool. People have just like memorized a rule like that. Okay. Do we have an alternate option for that? Hi, I'm Sarah. You are?
I'm also Ellie.
Ellie. Okay.
Well, I just remember that like in multiplication, one of them's if only one of them's negative, then make them just positive. So it's
That'll work.
similar.
Yeah, that'll absolutely work. There are all kinds of ways that we could dive deeper into that, but if people are comfortable with that, I will just leave it alone. This second piece is something that is more likely to cause confusion or a mistake. And there are 2 different ways that you could go about writing this. And I don't know which one feels better for you all, but I jumped straight to writing this as -10. And I probably could have written this as we're adding a -10, right? This was addition to begin with, and the multiplication result was a -10. Now I'm attacking the addition piece. Doesn't matter. Again, you do not have to write out all these steps. I'm trying to be explicit about it. So if I move on to addition, I have -27 plus -10. Everything in there is a negative number. They're combining together for me to come up with a -37 as an answer. Pausing there in case there are questions. Let's have more fun. So the reality is that most of the time, we're not really just dealing with numbers. We have to be able to deal with variables and parameters as well, which we usually use letters to stand in for. So I'm adding a new piece to our instructions right now. And that is this phrase, to combine like terms. I don't actually recall anyone ever explaining to me what that meant. I personally remembered just like having to figure it out from context. So I want to be explicit about what like terms mean. So let's dive into this like terms piece of it. For starters, generally we should be separating things if they're represented by a letter. We treat each letter like it's representing something different. So if I have some X's over here and some Y's and some A's and some B's, we treat each of those things like they represent a different value or physical commodity or whatever. These are not like terms. So if I had 3x plus 3y, they both have 3's in front of them, but they are not like terms because I am looking at 2 different letters. So I have 2 different variables here. I think where things tend to get a little bit more muddled, or where I see more mistakes with this, is if I had something like, let's say I had 4x plus 3x minus 4x squared. Now, if I asked you to simplify this expression and we were thinking about PEMDAS, I would walk through this and say, okay, I don't have parentheses. Oh, but I do have exponents. I'm supposed to simplify that exponent. If I don't know what the value of x is, I can't do anything with x squared. So it just became its own thing. Because until I know the value, I can't simplify that piece of it. Now, if I'm following PEMDAS, that next thing on there would be multiplication. I do have multiplication here. This says 4 times the value of x. But again, if I don't know what the value of x is, that's as simplified as it gets. So there isn't any multiplication that I can simplify. So I've got to move on to my addition and subtraction stuff. So in terms of addition subtraction, I do have these two pieces over here that just have a value of x in them. So those are the pieces that I can combine. These are like terms. So I am looking at a 7x, but because that negative 4x squared was a different thing, I'm not able to simplify that x squared, deal with that exponent because I don't know the value. I just have to leave it alone. And I could write that as 4x squared. Good times. Okay. Now for a more interesting example. Same instructions, we're going to simplify and combine like terms. But let's have 5 times 3x minus 2 minus 7 times 5x plus 3. I'm going to approach that. I'm trying to like give people time to write because I know it takes a second to write the problem down. If I'm going to approach this the same way that we have been approaching the other ones, and I'm thinking through PEMDAS, I'm going to look inside those parentheses and see, can I simplify anything now? Well, if I look inside of those parentheses, I don't know what the value of x is, which means I can't do anything with this 5x plus 3. These are not like terms. One of them has a variable in it. One of them is just a number. It's just a constant. And if I look over here in these parentheses, that 3x minus 2, I also can't do anything with that because I don't know the value of x. So I'm like skipping the parentheses piece. It's as good as it's going to get. Next up, I would look for exponents. I didn't give us any exponents this time, so we don't have to worry about that. Next up is multiplication. And now we get to talk about the distributive property. I will say our textbook has a bunch of like, I don't know, vocabulary practice. Is anyone a math major? Sweet. Y'all don't need the vocabulary practice. Okay, it's not going to come up. It's not going to come up in pre-calc. It's not going to come up in calculus. Like, no one's going to ask you to prove the distributive property. I'm going to use some of that language because it is mathematical language and it is in our book, but I am never going to test you on knowing the difference between the associative property and the distributive property. It's just not an issue. Is anyone an engineering major? Sweet. So engineering majors, second year of math classes, you're going to hear these words again and no one will remember what they are anyway. So they're going to teach you those words. Good times. Okay. So I'm about to use the distributive property. which means when I look at this multiplication, this 5 is being multiplied by everything that's inside of the parentheses. I like to keep track of that by drawing little rainbows. You don't have to draw rainbows. I'm going to draw rainbows. What I mean by that is I know that I need to distribute this 5 into the 3x and also to the -2. So I'm going to do 5 times 3x. I can't do anything with the x, but I can multiply the 5 times 3 and end up with a 15x. 5 times -2, I am looking at -10. When I come over here and I'm thinking about distributing that -2 in, I've got that -2. It's going to get multiplied by 5x. So I will have the blue showing up okay? Yeah, kind of. Okay. I'm going to have -10x. And when I distribute the -2 into the 3, I'm going to have -6. Now the other piece to the instructions, the combining like terms, means I'm now looking for things that are like. So my two pieces that have that x variable in them, those I can combine together. So 5x plus a -10x or 5x minus 10x, either way, I'm going to have 5x, -10 minus 6, or -10 plus -6, whichever way you want to think about that. I'm looking at -16. Okay, one for you all to do on your papers. Slide that up. Same instructions here. We're going to simplify and combine like terms if you can. And if you ever just can't read my handwriting, speak up. Oh, I also should have mentioned this, but I will, by the end of the day, I'll have these notes scanned and put into Canvas. So don't sweat it too much in terms of like if you miss something when you're trying to take notes in class. If I have written it in here, it's going to end up in Canvas. Oh, yeah, I know, I made this one up here. I think the final answer works out to be kind of, I don't know. People make value judgments about numbers. All numbers are great, right? That's made a value judgment about this number. I think is going to end it at 0. Some people like a little more time to play with it on your own. Okay, let's go like 30 more seconds. So you can wrap up. If you think you have an answer, you can always nudge the person next to you. Take the opportunity to learn their name and introduce yourself to the person next to you. Okay. I didn't say this before. There are many correct paths to get through this problem, which is annoying for most students. And that's going to be true for a lot of the work we do. There are many correct paths. I'm going to try most of the time to fall back on PEMDAS because I think it's comforting to have a process that's consistent, right? And so I'm going to try to focus on, can we have a process that's consistent? If you've got a faster way through the problem and it's getting you to the right answer, totally fine, okay? So I'm going to focus on PEMDAS, which means I'm going to go, okay, let's look at our parentheses. Is there anything we can do? And I'm looking at the first set of parentheses here. And there is something that I can do. I have like terms. I've got two parts that have X's in them and then just a number. So I can at least take that 4X and the negative 3X, combine those together. So this turns into X plus 1. I know I'm just doing one step at a time. I could be more efficient with my paper. That's it in terms of parentheses. There are no like terms here to combine and no like terms here to combine. So next up, I'm thinking about exponents. I have continued to not give us exponents. We're good. I'm moving on to multiplication. Here, I've got multiplication that looks like negative 10 times the stuff in parentheses. So I can do that distributive property thing again. I'm going to have my negative 10. I'm drawing my rainbows. Negative 10 times X. I'm looking at negative 10X. And negative 10 times 1. I'm looking at negative 10. If I move on to this other piece, I actually have three things multiplied together. 5 times 3 times 3. 5 times 2 times the thing in parentheses. I'm going to choose to do this kind of in order from left to right. You don't have to do that, but I'm going to deal with the 5 times 2 first, because 5 times 2 is. So if I've got a 10, then that is now looking like 10 times X minus 4. I've got my negative 10X minus a 10, and now I'm ready to do the distribution thing again. 10 times X, I've got plus 10X, and 10 times negative 4, that's a negative 40. My last step, I'm going to combine like terms. I'm going to go, oh, hey, I've got a negative 10 and a positive 10. Negative 10 plus 10. My least, oh, wait, yeah, okay, so simplify is my least favorite expression, like instructions wise. My least favorite thing that we say all the time is the word cancel. Negative 10X and 10X, I argue they don't cancel, they add to 0. 0 is our additive identity. So negative 10X plus 10X adds to 0X. Do we need to write the 0X? No, we do not. Is it fine if you use the word cancel? Absolutely. Negative 10 plus a negative 40 is going to give me negative 50. And that's looking like my final answer. Dun, dun, dun. I'm going to switch gears and talk about something completely different for a minute. Because Monday, Wednesday of next week, but really a lot of it on Monday, we are going to dive into the realm of fractions. I'm saying that because it's a scary F word. And The thing is, oh, are there any psychology majors or cognitive science majors? No, that's okay. Oh, yeah. Okay, so I propose this every year and no one has ever come back to tell me that they've done this. I am convinced that someone needs to do a psychological study. Because the moment that I even write a fraction somewhere, I think there's a part of your brain that turns off. Like not everybody, but I think there is this like flight or fight response that happens the moment someone puts a fraction on the paper. I don't know what we are doing to kids in 2nd or 3rd grade, but we are somehow breaking people when it comes to fractions. So I want everybody to know that on Monday, we're going to be talking about fractions. This is like your public service warning. We're going to be talking about fractions on Monday. And I'm going to do my best to make sure that no one's running away in tears, right? But if we're going to talk about fractions, there's something that's super helpful for us to do ahead of time. And that is prime factorization. Because it's helpful for a lot of different things. And I'm sure you've seen prime factorization before, even if someone didn't call it that. Here's what I mean by prime factorization. I'm going to pick a big number. The first one's not going to be too terrible. I think it's not going to be too terrible. So my number is going to be 240. And when we say prime factorization, just like if you were factoring something with x's and x squareds and numbers and stuff in it, we are trying to break this down into a multiplication problem. We're trying to break this down into the factors that if we multiply them together, we would get 240. So just hang with me for a second. I'll leave it up here long enough for you to write. But does anyone see two numbers that multiply together to be 240? What do we have, Ella? Wait, Ellie. Ellie, yes? Okay, Ellie. Cool. Now, 24 and 10, neither of those are prime numbers. Does anyone know what it means to be prime? Or rather, is anyone brave enough to give their version of a definition of prime? Cool. I'm going to keep it real simple. It's prime if the only way to get that number with multiplication is 1 times itself. Oh, I should say multiplication of like whole numbers, where I'm gonna get weird with decimals and fractions and stuff, but multiplication of whole numbers. So neither of these numbers are prime. Someone give me a multiplication problem that equals 24. Anyone have a multiplication problem that'll get me to 10? Great. So if I did 6 times 4 times 2 times 5, I would get to 240. But I'm still not done because I was looking for the prime factorization and we're not quite there yet. Because 6, I can break down further as 3 times 2. And that 4, I could break down as 2 times 2. 2 is prime because they're the only numbers I can multiply to get 2 is 2 and 1. 5 is also prime because the only numbers I can multiply by are 2 and 5. So what that means is that 240 is equal to 3 times 2 times 2 times 2 times 2 times 5. Or if I put this in the shortcut notation, which is how the answers in the back of the book are going to look. Oh, I say back of the book as if people have a physical book. Yeah, the appendix that if it were a physical book would be at the back of the book. That has the answers. All of these 2's, since I've got 4 of them multiplied together, my shortcut notation for that is going to look like 3 times 2 to the 4th times 5. And for reasons that don't really make sense, but again, conventionally, these get ordered from the lowest prime to the largest prime. I couldn't care less. Any of these 3 are all great answers. Oh, I lost an R in the word great. These are all great answers, and I don't care which form you choose to write something in. So now we're gonna do another example or 2, maybe if we've got time, but I want to pause for a second to talk about some nice numbers. If it's been a minute, oh yeah.
I was just wondering if you had a number like 240.
Yeah.
Why would you want to write it down?
Oh, fantastic. We'll skip the nice numbers because that's a much better thing to talk about. Okay. So I mentioned that we were going to talk about the dreaded F word on Monday. We're going to talk about factoring. Let's say that I asked you, my least favorite thing, to simplify. Let's go with 15 over 240. Nope. I'm going to ask you to do 240 divided by 15. Some people love long division. Woo! Me either. I'm not going to do long division on this. Instead, what I'm going to do is prime factorization. So that 240, well, we just did all the work, so I'm going to steal it. We did all the work. We got 3 times 2 times 2 times 2 times 2 times 5. 15 prime factors are pretty quick. That's 3 times 5. I try to not use the word cancel because we actually mean 2 different things when we say cancel. Sometimes we mean the things equal 0 when you put them together, and other times we mean that it equals 1. And the reason for that is that our additive identity is 0 and our multiplicative identity is 1. Again, I'm using fancy vocabulary words, but I'm not going to cancel things. I'm going to find secret ones in a problem. So when I look at this now, 3 divided by 3, well, that's a secret 1. And 5 divided by 5 is also a secret 1. And now I know that 240 divided by 15 is equal to 16. That is one way in which we're going to use prime factorization. And certainly anytime I'm looking for a common denominator, I'm probably going to end up using prime factorization, whether I realize it or not. If the numbers are small, we're kind of used to doing that prime factorization stuff in our head. And when the numbers get big, I want to make sure that we're explicit about it is a tool that we can use. So I think I did that right. 2 times 2 is 4. Times 2 is 8, times 2 is 16. Yeah, okay, we're good. We got to 6. Cool. We have a little bit of time. So now I'm going to go back to my nice numbers stuff. And if it's been a minute since you were doing math with numbers in your head or without a calculator, I am asking you to memorize some stuff. We'll get to general multiplication facts like everything up to 12 times 12. We're gonna revisit that, especially when we're doing more factoring. But for right now, I actually am just looking for you to memorize some nice square numbers, cubed numbers, and things to the fourth. So I'm gonna make a quick list of what I expect you to work on memorizing over the next couple weeks. So 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64. I run off the page yet. 9 squared is 81, 10 squared is 100, 11 squared is 121, and 12 squared is 144. Anyone know 13 squared? Cool, that's 169. In terms of cubed things, and the reason that I call these nice numbers is these are values that instructors are going to put in problems, but textbooks are going to put in problems because they think they've given you nice numbers. But if we don't recognize what's nice about them, then it can slow us down in a problem. In terms of stuff cubed, I don't expect you to go as high. So 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. You got that, we're good. 2 to the 4th, I really kind of expect you to be able to quickly double things in your head. So if it's 2 to the 5th or 2 to the 6th, like you should be able to double those things in your head. But powers to the 4th, really, it's kind of just these 2. And that's probably good enough. I am out of time. Thank you all for hanging out with me this morning.